Okay, let's go to part 2 of chapter 2, Stokes theorem. Okay, Stokes theorem is the higher dimension of Green's theorem. So, for Green's theorem, you consider two-dimensional figure here. Okay. This is Green theorem. But for Stokes theorem, you consider the 3D, the three-dimensional surface. So we have extra here. X, Y, and also Z. Okay, let's look at the differences between Green's theorem and Stokes theorem. Okay, both determine a both state relationship between line integral and also double integral. Okay, but for Green's theorem, it is for 2D, Stokes theorem for 3D. Green's theorem and Stokes theorem, we consider positive orientation only, which is counterclockwise. For Stokes theorem, we have the line integral f dot dr equal to double integral of S, surface S, curl F dot with ds. This S here refer to this surface that bounded by this curve, this C. So basically for Stokes theorem, you have curve and also you have surface. Let's look at positive or negative orientation. Okay, for positive orientation, okay, the curve is counterclockwise. The direction of the curve is counterclockwise. Okay, you can use the rule of right hand rule. This is your right hand. When you close your right hand and point it upward, so this is refer to the normal. If the unit normal, this one is unit normal, is pointed up. So the curve is follow counterclockwise direction. But if your hand pointing downward, your direction, jari jemari ni, is clockwise. It follows clockwise direction. Okay, let's look at the definition for Stokes. Okay, C can be the simply connected, piecewise, smooth, closed curve for surface S, which is oriented surface or open surface. Okay. And we have F here, consists of P, Q, and R. Okay, so Stokes theorem is defined as, okay, this one is line integral. Saya lupa nak tambah. This is line integral. This one is, you can say that's surface integral. For surface integral here, equal to double integral of S curl F, where this curl F equal to del cross with F equal to I, J, K. Here I, J, K. Here you put del. Del over X, del over Y, del over Z. And then this one you put P, Q, R. Okay, this is how you find this curl F. Okay, same with Green's theorem. Okay, if the question asks you to verify, then you must calculate both sides. Okay, first calculate this left hand side, and then you calculate right hand side. And the answer must be the same. Kena sama, equal. Okay. If the question asks you to evaluate, you just calculate one side. Okay, to do the right hand side, curl f, this curl f, the double integral. First step is to find curl f. You calculate curl f. Then find n. N is the unit normal surface. So n is depend on your type of surface. We have parametric surface and non-parametric surface. So if the surface is cylinder or sphere, you will use this formula. Okay, but if the surface is tetrahedron, paraboloid, cuboid, okay, non-parametric surface, you will use this table. Table 2.4. Okay, then step number 3, dot product both curl F and also N. Okay, here after you dot product, then okay, for parametric surface, you change to polar coordinate. Okay, for non-parametric surface, okay, for parabola, you change to polar coordinate first. Okay, parabola is special case. And then for other surface, you change from 3D to 2D. Remember here we want to determine the flux. Ingat tak? Surface integral. The flux that flowing through the surface. Okay, step number 4, solve the equation. Solve the integral. Okay, let's look at example 1. The question asks you to verify the Stokes theorem. Hence, you must show both sides. Okay, for this F where surface S is sphere. Okay, we know that this is sphere, parametric surface, bounded by Z greater than 0 with upward orientation. Okay, first you must draw the surface. Okay, if you put here x square plus y square plus z square equal to 9 in 3D calculator, okay, you will get one sphere, right? Okay, one sphere like this. One sphere. But we want z greater than 0. That's why we are considering this surface only. Okay, z greater than 0. So first, to answer this question, first you must calculate the line integral. Okay, left hand side. Remember, for line integral, we change f, we change all to t. Okay, find the r. Okay, first find r. R is x, y, z. Okay, since this is circle, our curve now is circle. You get your figure, get your surface. This is our curve, C. Okay, so for line integral, we just consider this curve only. Okay, we choose counterclockwise. Okay, positive orientation. Okay, we choose here. X equal to r cos t, r equal to 3. So 3 cos t, and so on. And then substitute, we get negative 18 pi. Okay, I want to show you right hand side, which is curl f dot n ds. Okay, first step, find curl f. Okay, curl f. So then put PQR here, PQR. So 2y, 3xz, and z. And then solve. When you write in vector notation, equal to negative 3x. This one is 0. And 3z minus 2. Okay, then step number 2. Okay, find n. Unit normal. Okay, since this surface is sphere, which is parametric surface, then n equal to del s over magnitude of del s. S here, our surface, s equal to x square plus y square plus z square equal to 9. And then find del s. 2x, we get 2x, 2y, 2z. Okay, then find the magnitude. 2x square plus 2y square plus 2z square. Square root. You will get 2x, 2y, 2z over 6. Okay, simplify. X over 3, y over 3, z over 3. Okay, step number 3. Dot product curl f dot product with n. So curl f here. Negative 3x 0, 3z minus 2 dot product with x over 3, y over 3, z over 3. Okay, multiply. Then you will get negative x square plus z square minus 2 over 3 z. Here, we know that we are considering sphere. Then, you must change x, y, z to polar coordinate of sphere. Okay, this is polar coordinate of sphere. And then substitute. Here, x with r cos theta sin theta, z with r cos theta. Okay, substitute all. And then here you can substitute values for r. R equal to 3. When you look at the figure. The radius equal to 3. Okay, why we can substitute R equal to 3 here? Abdullah Saleh.
Yes.
Why here we can substitute the values for R? R equal to 3.
Because we will not integrate to R, I think.
Yes, excellent answer. Because we will not integrate to, here we don't have dr. That's why you can substitute R with the values. Okay, good answer. So the final answer will be after you simplify equal. Okay, this is step number 2. Then step number 3. Okay, substitute all. Okay, to solve. Okay, panjangnya. Okay, here the S equal to. Okay. So 9 sin theta d theta d phi. Okay. Then we want to determine the limit. Okay, this is our graph. We have graph tadi. Half sphere. Kita baru je belajar ni. We have theta and we have phi. So phi pi over 2. So for phi, 0 to 2 pi. Okay. Sini 0 to pi over 2. 0 to 2 pi. Okay, then you solve. And then the final answer will be equal to negative 18 pi. I already I already showed the complete answer in notes. You can refer your notes. Basically, Stokes theorem, let's recall. It's the relationship between line and also surface integral. So we have line and we have surface. So for this line integral given by this formula CF dot TR. And for surface integral, it is given by, okay, this is curve C. This one is surface S. So to do surface integral, double integral of S, okay, curve F dot N ds. Okay, to find this double integral, first you calculate curl F. Step number 1. Step number 2, find N. Okay, based on the type of the surface. Okay, step number 3, dot product both. Okay, step number 4, solve. Okay, let's proceed to example 2. Okay, here we have vector F, which move on the surface S, which is a plane of this one in the first octant. Okay, this is tetrahedron. When you draw, X, Y, Z. Okay, the intersection is given by this constant. Okay. So 1, 1 and 1. Okay, this is our surface. Okay, remember Stokes theorem, we have two parts, curve and also surface. So we know that this is our surface. So where is the curve? Okay, C is given by this line that follows. Dia cakap apa? Upward orientation. Okay, upward orientation positive. So this figure follows counterclockwise. This question asks you to evaluate the line integral. So no need to calculate line integral. You must calculate the second part, which is the double integral, surface integral. Here we want to calculate S curl F dot N ds. Okay, first find curl F. Okay, then you put here PQR. So this is our P, Q and also R. X minus Y, Y minus Z, Z minus X. Non-parametric surface. equal to 1, 1, 1 in the form of vector notation. So curl F equal to 1, 1, 1. Okay, step number 2. Find N. Okay, since this is, then you must refer to the table. Okay, we have upward orientation, okay, positive orientation, and our equation in the form of Z. So Z equal to, here, X plus Y plus Z equal to 1. Okay, jadikan X perkara rumus. So Z equal to 1 minus X minus Y. And then look at table, we choose this one. We choose this formula for N. N equal to Z over X minus Z over Y 1. Okay, differentiate this one to X. So equal to 1, 1, 1. Okay, same. So normal vector, unit normal for this surface equal to 1, 1, 1. Okay, next, step number 3. Curl F dot product with N. So 1, 1, 1 dot product with 1 equal to 1 multiply 1 is 1, 1 plus 1 plus 1 equal to 3. Okay, so this surface is non-parametric, right? So you must change to 3D to 2D. Okay, we want to consider, okay, this is our surface in 3D. Step number 4, determine the limit. Okay, subject 3, okay, dy, dx. And then determine the limit. First determine limit for x. Okay, so x here, we know that the intersection is 1. So x from 0 to 1. Okay, what about y? Y equal to 0 here, the lower part is 0 until here, this line. Until y equal to this part given by this formula of here, tetrahedron. We have z equal to 1 minus x minus y. Here we are consider at xy plane. So z equal to 0.
Okay, that's all for
Z equal to
today.
0.
Thank you guys. See you later.
And then rearrange. Y equal to 1 minus x.